So, graphically, yep. So what we're going to do here is we're going to deal with systems of equations. Okay, what does it mean to be a system? Think of the solar system. We're talking about many planets, many celestial bodies that revolve around the sun. So we're not talking about a celestial body, but we are talking about a grouping. Instead of dealing with one linear equation, we're dealing with systems of linear equations. And how are we going to solve them? Graphically. You know what that means? With a graph. That's all it means. Okay, so Max and his brother Eru, who's faster?
Max.
How do you know that?
Because he gave him a head start.
Okay, he gave him a head start, but it also says, how fast is Max? He runs at 6 yards per second. And how fast does his brother Eru run? 4 yards per second. So we know Max is quicker. And then do you notice here that they didn't start at the same point? Okay, who got the head start? Eru. That means this. If they're having a race, or I guess they're racing, but Max is eventually going to catch up to his brother Eru. And you can calculate that mathematically. So how are we going to do it? We're going to do it with a graph. Okay, the first way we're going to do it is we're going to talk about Max's distance. Okay? So Max's distance, how fast is he? 6 yards per second. How long did he run? I don't know. We're going to figure that out. Speaking of equations, do you guys remember what distance equals rate times time is all about? Do you guys remember that? It's right here. So how far did Max run? I don't know. How fast was he? 6 yards per second. How long did he? Like how much time did he take? Don't know. But I also know that his brother Eru is how fast? 4 yards per second. How long or how much time did he take? I don't know. But I do also know something here. He got a 20-yard head start. So he got 20 yards above Max's amount of yards at the beginning, right? The very beginning. We're trying to find out when did the two meet. So if I'm trying to draw this like in a little diagram I have here, Max. So that's Max is distance. Yeah, you can. I would draw it to help you visualize things. Now Eru, he had a 20 yards head start, right? So he started right here. When are they going to meet? That's what I'm looking for. And that's that's Eru. And I asked Max how you say that, and he said it's fine, Eru. A lot of people call him Eru, but we'll go with what Max says. Okay, so is Max eventually going to catch up with them? Yeah, because he's going faster. And when he catches up is what we're trying to answer. Okay, so here are my two equations, and I'll put here maybe to help you guys out. That's Max, and that's Eru. And that's a little diagram of what's happening. So I'm going to graph this here. And I'm not going to, when I do my graph, I'm not going to focus on the second, third, or fourth quadrant. So you guys remember you have quadrants. Why am I not dealing with the second, third, or fourth quadrant in this problem?
Because it's not going to be negative.
Yeah, we're not talking about negative distances. We're talking about, or negative times. We're talking about all positive time, positive distance. Okay. What are the two variables in this problem? Time and distance. Which one should go on the y-axis and which one should go on the x-axis? Which one's independent? Which one's dependent? That's from that class, isn't it? Okay, so you guys help me out. Which one?
Distance should go on the y-axis.
Okay, the y-axis is going to be distance because the y-axis deals with the dependent variable. Doesn't the distance depend on how long he's been running? How much time he's been running? So this is the dependent variable. And we're talking about yards. So we're talking distance in yards. Not miles, not feet, not inches, but yards. And then therefore what goes on the x-axis? Time. And we're talking about what? What kind of time? Seconds, okay? We're not talking about minutes or hours or days. We're talking about seconds. So hopefully pretty rapid. Okay, I'm going to go with... I'm going to go by 20s. And I'm going to go by 20s on the distance. So I'll go here 20. And I'm not expecting you to know how to do that but that's just what I'm going to pick. And time I'll go with ones. Okay, time is just my ones. Okay, let's look at Max's graph. Do you guys remember what form that's in? So this is a review here. Y equals 6x. Slope well, I see the slope, but what's the intercept? Yeah, you could have done this. You could have put plus 0. So where does Max's graph start? Where do I start this graph at? 0, 0, 0 right there. What's the slope? 6 over 1. Now this is tough for the graph, trust me. I'm going to try my best. I'm going to go up 6 over 1. And I'm estimating here because obviously counting by 6 is not going to be easy here. Then I go up 6 more, over 1, up 6 more, over 1, 6 more. Okay, and I'm going to extrapolate. Do you guys know what that word extrapolate means? It means extend that line based on what you already know. So you see how I kind of made the line keep going, something like that? Okay, I'm extrapolating. Did I go slope anymore? Did I do the slope on this part? No, I just kept that line going because that's how fast it's going to go usually. Okay, Eru, where does he start on the graph? 20. He starts up here at 20 because he already had a 20-yard head start. And what's his slope? What's his slope? 4 over 1. Up 4 over 1. Up 4 over 1. 4 over 1. 4 over 1. Okay, and I'm going to extrapolate that one. Ooh. Now, are those two graphs ever going to intersect? Okay. Now, Mr. A is going to do a little confession here. I didn't draw the best graph. But thankfully in our book, do you guys see on the bottom of page 150? Where do those two lines intersect? 1060. So they're going to intersect here at 1060. What does that even mean? Does anyone know what that means? 1060. That's where they meet. 1060. Do you remember what the x-axis or the x variable stood for? It stood for, so 10 seconds. What did the y variable stand for? Yards. Do you know when those two guys meet? In 10 seconds, 60 yards out. So right here, Max started, he was going 6 yards per second. Eru started with a 20-yard head start. He's going at 4 yards per second. And how long does it take Max to catch up to Eru? 10 seconds. And how far was that? 60 yards. What I'm trying to point out here, guys, is that these two separate graphs can be put on the same coordinate plane, and you can tell me when they intersect. And do you guys see that on page 150? Do you guys see that they do intersect at 1060? So that's when it's going to. That's how long it's going to take Eru to catch up, or sorry, Max to catch up to his brother Eru. Is it going to take long? What do you think? Is 10 seconds fast, by the way? Okay, 10 seconds is not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, he's really quick. 1, let's count to 10 all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there, he's going to catch up to his brother. Right? He's running at his, I hope, his full speed, 6 yards per second. Eru is running at his 4 yards per second. Eventually going to catch up. Okay, this point right here where they would have met, this one right here, that is called the solution of the system of linear equations. How many equations were we dealing with? 2. What's the solution for both of them? 1060. And I'll emphasize that a little bit more here. Oh, I didn't need that. All right, let's go ahead and look at this right here. Go ahead and write this down. We are going to graph these. How do I know that this is a system that we're talking about? Do you guys notice this little symbol right here? What do you have there? A brace. And it's one brace on the left side. Is there a closed brace? No, so just one brace. It's saying that these two are a system, and I want to find the solution to that system. And you're like, how do you do that? Well, what do you think we have to do in these problems on this chapter, in this lesson? Graph. We have to graph them. Looking at the first equation, so I'm going to rewrite it up here. What form is the first equation in? Do you guys remember what form? Standard form. How many of you are good with saying negative a over b is the slope and c over b is the y-intercept? Anyone? Can anyone do that? Okay. What's the slope then of this equation? Negative 5 over 2. You got negative a over b. You got your slope. What's the y-intercept? 6 over 2 is 3. That's your y-intercept. You get it right there from standard form. How many of you can do that? Good. How many of you are like, nope, didn't see that? It's okay if you didn't see it. How many of you didn't see it? Okay. If you don't see it, what else can you do to the standard form equation to get that?
Can you subtract 5x from this?
Yeah, you're trying to get it into one of our favorite forms, slope intercept form. So you said subtract 5x from both sides? Yes. You're going to get that canceled out. 2y equals, I'm going to put the negative 5x first, plus 6. Is that all we had to do? Then we divide both sides by 2. That means everything gets divided by 2. And look what we have here. Y equals negative 5 halves x plus 3. Does that look familiar? What's the slope here? Negative 5 halves. What's the y-intercept? 3. So you can get it either way, however you want to use it. All right, on your graph, go out 5 each direction. Now, for the most part, your graphs are doing pretty well. You don't have graph paper right now, but try to do your best to get these spaces equally spaced out, because if you don't, your graph gets messed up and the solution's not super clear. So guess what I have for you today in just a moment? Graph paper. Do you know why I gave you graph paper? Yes, good. So you can be neat, and in being neat, you can find out your solution. Because right now, I'm hoping I get it. I'm really hoping I can get it without my graph paper. Okay. Can anyone graph this first line? Tell me how to graph this first line. Where do I start, Murphy? On the y-axis. All right, 1, 2, 3. So here's my first dot. And where do I go from there? Oh, go ahead.
You could go up, or you could go up.
Okay, go up 5, and then you'd go.
To the left.
Good, good, good.
It might be easier to go down 5 and to the left.
2, 3, 4, 5, 2. Yeah, in this graph, in this case, it would be easier to go here. Oh. Okay, so that would be my first line. Great. Oh, what form is that second line in? It's kind of like a weird form. You could say it's standard technically, but it's a special line. You guys remember what kind of special line this is? Automatically. Vertical line. How do you know it's vertical? It says x equals something. So where would the vertical line go? Because the vertical line could go here or here or here. Where does it go? Where x equals 2. So this is where it would go, and it's a vertical line. So it should look something like that. Okay. Is this what you have on your paper? Okay. Where do both of these lines meet? They meet at 2, negative 2. Why you go 1, 2, and then down 2. So 2, negative 2. Okay, I'm going to ask you a few questions here to show you what we're trying to figure out here. How many solutions are on the first line? How many solutions are on this line? Infinite number of solutions. How many solutions are on the second line? Infinite number of solutions. How many solutions do both lines share at the same time? So how many solutions? One solution right here, and that's at 2, negative 2. That's your answer. That is the solution to the system. Because there are an infinite number for the first, infinite for the second, but for the system, there's only one. It's right there. Yes, ma'am.
So like, I think you just said it, but they
Awesome.
only intersect once. Right?
One time, yep. Because this line will go, and the only time they would have ever crossed paths was right there. Mm-hmm.
What if you have like squiggly lines?
You can get squiggly lines, but not linear equations. So, thankfully, we're talking about linear. Are they always linear?
Yes.
No, you're going to talk. We almost had non-linear last chapter, but you'll definitely get it later on in the year. Yes, ma'am.
So, if this is just one type of system, but we're going to learn about this where they intersect.
Mm-hmm.
Okay.
Other systems in just a moment, but here's what I want to say. We said this is a solution to both of them, but aren't solutions checkable? Can't they be checked? Okay, look at the bottom equation. Look at my ordered pair. What does x equal in my ordered pair? Does 2 equal 2? Yeah, that works. This checks. What about here? What does x equal again? 2. What does y equal? Negative 2. What's 5 times 2? 10. What's 2 times negative 2? What's 10 minus 4? It checks. It's the only ordered pair that fits both of these at the same time. How many ordered pairs are here? Infinite. How many ordered pairs are there? Infinite. How many ordered pairs for the system? 1. Notice I'm trying to emphasize something. All right, let's go ahead and I want you to graph these two on your own. So you figure out whatever method you want to use. If you want to make them both slope-intercept, or I like standard form, I can do it that way. Whatever you want to do, you graph them. What's the first equation in, by the way? What form is the first one in? Standard. What's the second one in? Slope-intercept. So if you want to keep them like that, great. If not, you could change that to slope-intercept as well. And then you can graph that one, I hope. Is anyone still struggling with graphing? I'm here to help you out. Good with graphing? Okay. Anyone struggling with graphing? Okay, because I'm here, waiting, wondering.
Did we still do 5?
5 by 5 should be enough.
Okay. Sorry, that was really slow. I guess
Yeah.
that.
Is that what it looks like?
Yeah.
Uh-oh. Caroline, how many solutions are on the top line? How many? Infinite. How many on the bottom line? How many does this system share? Sorry?
2.
2 points? Do they share 2 points?
Oh, no. So are you meaning like where they
Yeah, where they...
intersect?
Yeah, how many times do they intersect?
Yeah.
Why do they never intersect? They're parallel lines. There is no solution to this. In fact, that's my answer. No solution.
'Cause they-
Why? Because they intersect. That's my answer. No solution. 'Cause 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 they intersect. That's my answer. No s Are there any points that these two lines share at the same time? No solution. They'll never intersect. Parallel lines do that. How do you know that they were parallel lines? They had the same slope and they had different y-intercepts. Yep, that's how you knew that they were parallel lines. Now, if you already know that they're parallel lines and it says they're graph, guess what you have to do? So you still have to graph it. Just prove it. Prove that they're parallel by graphing them, and then you can also find that out mathematically using the equations. Okay, so far we see that lines intersect at one point, or they never intersect. Is that all?
Nope.
Huh. Graph these right here. Try these out. Mr. A, we're doing a lot of graphing. What's this lesson called? Solving systems of linear equations graphically. Yeah, so graphing them. Did you have a question? Okay, that's all right.
Wait, was there a brace on the last sheet?
Let's say I hope so.
Oh, okay.
Yeah, so you can put your brace. Yep, and when you see that brace, you know that those two equations, I'm trying to find the solution for both of them at the same time.
So it's negative a over b to 1 equal, is that right?
Mm-hmm. So, okay, I'm going to write stuff on the board. Don't just copy it without trying to understand it. If you're like, where did he get that number? Ask. And I'm more than happy to help you out because you're going to have to do this on your own. For the first equation? Mm-hmm. Is it in standard form? So then I could do the negative a, which is negative 1 over 2. And then c over b is 2 over 2. So I got those points, or I got those parts. Oh my. Someone in the other class told me what to do here. What do you guys see to do here?
Can you just rewrite it?
I mean, you could rewrite it. Yep.
You make it all positive.
How do you do that?
You just take away the negative on the 3.
Okay, but how do you do that? Like you got to do it properly. You got to do something.
Oh, divide by 1.
Divide everything by negative 1?
Negative 1.
Okay. I'm going to take it a step further. I'm going to divide everything by negative 3.
Oh, yeah, I guess that'd be easy.
Because then I'm going to make these numbers smaller as much as I can. So I get x plus 2y equals 2.
They're the same line.
Excuse me?
They're the same line.
Okay. Always mess up that first line. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3. Okay, I'm going to graph that first line. It starts on positive 1 on the y. It goes down 1 over 2, down 1 over 2, or up 1 over 2 to the left. Okay, that's the first one, right? The second one, I'll go through it. Are you sure about that?
No.
Yes.
Okay, I'm going to look at the y-intercept, which is 1. Okay, they happen to share the same y-intercept, but then what's the slope? Down 1 over 2, down 1 over 2, up 1 over 2. How many solutions are in the top equation?
Infinite.
How many solutions are in the bottom equation?
Infinite.
How many solutions do they share together at the same time? This is different from what your book says, but this is accurate. Infinitely many. Infinitely many would be your solution. How many are there that they share together? Many. How many? Infinitely many. The reason I say infinitely many is not because that's a cool thing to say, infinitely many, think about that, but it's accurate. Does that mean that anything works? Does that mean that any numbers will work? No. It means that there are many numbers that will work and there are an infinite number of numbers that will work. And you're like, wait, you just said not all numbers will work. I mean that. Does this point work?
No.
This point? There's infinitely many that don't work, but how many points do work? Infinitely many. And they're on the same point. Give me a point on the line, by the way.
72.
No, this is right here. Yeah. 2, 0 would be one, right? 2, 0. Is that one?
I was thinking 2, negative 3.
Yeah, 2, negative 3 would be down here somewhere.
Sorry, negative 3.
Negative 3, 2. I don't. It may work. I don't know because my graph is kind of off. But 2, 0 does work. All right. 2 plus. What's 2 times 0?
0.
What's 2 plus 0? Check. It works. Negative 3 times 2? Negative 6. What's negative 6 times 0? What's negative 6 plus 0? Check. It works on that one. And you know how many numbers, how many ordered pairs are going to check? Infinitely many. Not infinite. Infinitely many.
Negative 72, 74 works?
Say it again.
Or no, 74, negative 72. We should check.
You should check it, yes. I'll let you check it. Okay, what are the 3 types of solutions we're going to get today? We're going to get an ordered pair. Sometimes there's only one answer. Right there. They intersect at one point. Sometimes they are parallel lines, so you'll have no solution. And sometimes they will be the same line. So how many solutions are there? Infinitely many. And you must put infinitely many. Yes, ma'am.
So for the checking, so you just take a point on the line and then see if it works?
For both of them?
For both of them.
Both of them, yep. And if they work for...
Both of them.
Same point for both of them. If they work, that has to be a solution. If they don't work on both of them, they may be a solution for the top, they may be a solution for the bottom, but they won't be for both of them, and they're not counted. Because we're trying to find the solution to the system. So both of them at the same time, which means you're usually going to have one, none, or infinitely many. Okay, I'm going to see if you guys are getting this. On page 153, I want you guys to... graph number 2. Now listen to me carefully. Before you graph, don't graph, guys. Please don't graph. I'm trying to be nice to you. Use this paper. Use this paper. I'm trying to be nice, not being mean. It's nice paper, by the way.
I wrote that chart down here.
Yeah, we'll look at that this afternoon more. You can use your note paper to solve, but then when you're graphing, use this graph paper. Trust me, some of you are in for a heartache if you don't do it.
Why is that diffraction?
You can have a y-intercept fraction. That means you had to go up 2/3, right? Is it 2/3? And that is a little bit tough, but it's manageable. I'm sorry, Murphy, I gave a couple papers for your row. Sorry. Yes, sir? Number 2 on page 153.
We're just using this for this problem, or we're using this as one?
You can use it for your homework as well. So you can use it for other problems. Okay, yeah, it's this problem right here. Sorry for the purple. Yeah, I would do graph paper.
So we solve it on the note paper and then graph it?
Graph it on your graph paper.
I just solved on my graph.
That's okay, yep. Yeah, just use a graph paper at least to do the graph. Don't be afraid of fractions, although if you're not careful, it is going to mess you up. Let me ask you this. If you got these parts on for your graph, are they going to intersect? Look at your slopes. Are they going to intersect? They have to, because they're not the same slope. So they have to intersect. I don't know where they intersect. That's the whole point of the problem. Okay.
It'd be 5 by 5.
5 by 5 should be enough. Yep.
You know for sure that they intersect. Because you're kind of just like, you still have to guess because it's refraction.
Yeah, but the way I know that they're going to hit each other at least one point is that their slopes are different. So if they're parallel, they'll never hit. But other than that, they will always hit somewhere. And that somewhere is where I'm trying to figure out. Okay, on this graph, if you are done and you get the point where they intersect, I'm going to come and check it. And if you did well, I'm going to let you graph it up here on the board to show your classmates. So that's if you finished and you get it correct, which is not easy because these are not easy. Okay, question?
I like somehow because I sort of like. I think I curved it on my own.
Yeah, I think it's curved a bit. I think if you just like, do you have something to make it straight, that line? Because I think it'll. Yeah, I think if you straighten those out. And this one's kind of like right there, so it's a little less. Yeah, it's tough. This is tough, Sarah. Close. Look at your point.
Oh, no, I'm wrong. I got it. Mine's a little bit.
It's a little off. Yeah. Oh, what's your point? What's your final answer? So I'm going to check around here. Close. Look at my slopes. They're both what kind of slope? So they both have to go down.
You'll have one right, but then
The other one has to be changed.
So this is
It can't be right. Yep.
know what I did. Over 30.
Now, this is this one line?
Yes.
What's the slope of this line? Is it that one?
No, it's this one.
Okay. It's a negative slope, so could it be going up? So change that up. So that's getting there. The point, let's see. I'm not sure about that point is not correct, but your lines aren't that bad.
I thought it was somewhere you put 2/3.
Yeah, like you would put, can I see your pencil?
Yeah.
Like this would be 1.
Okay.
So you'd go 2/3 is like right about there.
Okay.
On this one, this line looks okay, but this line, what's the slope of that line?
You go up 2 over.
It should be down to over 3. So it's a negative graph. Check it. Close. Yeah, tell me where that question mark.
When it says to go like down to,
So you'll go, oh, okay, so you'll go, so here's down 1, down 2. So it's kind of like you're off the line and then over 3.
Okay.
It's getting there, but yeah, it's not bad. But you know what? I would say, Nick, use the lines they give you, because you notice how me and you are going to have a hard time on this problem because I don't have equal spacing, and then it's going to make it messed up. But if I have equal spacing, which they give you, it's going to make it a little bit easier. You're close.
I don't know what I went through it.
I know what happened. This is the 2/3 one?
Yeah.
So you had to go down to 1, 2, over 3.
Oh,
so you're a little bit further down, so it's got to...
Okay. Okay. How did you said you have like the approximate here, so you go down to 1.
You got to go 1. You got to go 1, a full 1.
Oh, okay.
2.
Why do you skip that?
Well, this is the hard part. When you went down 1, you go all the way down here.
I did the same thing.
Because it's a whole space that you go down. Yes, ma'am. Okay, the graphs look good. That's not the solution though, and I'll show you why.
Wait, Mr. Why
You're close. Yeah, but no. Sorry. No, sorry. You're getting there.
What'd you get, Y?
Okay, this is what we're going to do. Mr. A is going to go through the same process you did, and hopefully I do it better than the last class because it was awful. The first graph starts at 2/3 and goes down 2/3. So 2/3 is like right here, down 1, 2, 1, 2, 3. Up to 1, 2, 3. Okay, I think it's right about there. I'm going to connect these, something like that. Okay, that's the first line. The second line starts at +2, and it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Now listen, hold on.
I got it right, Mr. A.
Now listen to me. And I think I told one of you, my graph is it's kind of messed up because it should be right here, but it's kind of right here. Okay, this is what I want to tell you. I'm not going to give you tough ones like this one, but how many of you realize that this is hard to do? It's hard for me. And I actually did better than last class. It was like way off. But this is where they meet. What's that point? 4, -2. Yeah, I think one of you got it right. 4, -2. Now listen. Some of you are very close, like this right here. 3, -2. That's very close.
Yeah, I can
Who wants to admit how close they were?
Is this
1/3 away? No. Oh, yes.
Okay,
Oh, yeah.
Mystery, I was far. I went like the
You were close. Yeah, you were very close. Listen to me very carefully right now. I'm not going to give you these problems because the fraction throws me off. That should help me to realize this. Graphing is good when they look like this. That's good. I could do that. That's not too bad. Well, that was awesome. This one is great. But when we start getting graphs like this one, that's where it gets tough. There's got to be a better way. And guess what 6-2 and 6-3 are all about? The better way. But before that better way, let's trudge through the more difficult way. Number 4. Do number 4. On page 153, number 4. Yes, use your graph paper for this. This one is manageable if you're neat. And some of you are getting there. Although some of you maybe need to use your paper better. Use that paper.
Negative would be.
It'd be -2 over -1, which is 2.
And then I have
-8 over -1, which is 8. 8 is +8.
So what I would do is that, or just.
Sorry. Can you see your pencil?
Yeah.
This number right here is your slope, and this is your y-intercept. So they're separate. This one I'd go up like 10 on every direction. Yeah, go 10 because your y-intercept is big. I'd go 10 I'd go all directions 10, but I mean you don't have to.
I'm kind of doing like the problem part on divide by 2.
Oh, you could, but your whole goal is to get y by itself, right? Is that what you want?
But it's going to be
Yeah, so don't worry about that yet. Just what do you do to get rid of yes? Subtract that from both sides, and then you're left with -y equals -2x minus 8. Then you're going to, how do you get that to be positive y?
divide by y.
But divide everything by -1. So basically all the signs change.
Whenever you just have a y-intercept, how are you supposed to get?
Yeah, it's a special line. X equals something is like that. Y equals something is like that. You know, I'm going to take it back. That last problem you did, I'm not going to give you many of those. I might throw in 1 or 2 because I want to see how you guys deal with it. I think you can handle it. No. For the homework.
Ooh, give us a bonus.
For the quiz, I don't know. I can't answer that question.
Give us like a super duper hard one and make it a bonus.
Yeah, make it worth like.
10 bucks.
If you get that one, it like that substitute the entire
For
course.
the whole quiz.
Make it like 6/7 or something. You're like 18/24s.
Yeah, reduce that for
73.98.
Yeah. So then
Don't
you
do that.
Great. Thank you for the
make that
suggestions.
slope.
All right. If you have a solution, I'm going to come around and check it. Make sure I get it. Okay,
They
good.
got it right.
I'm still thinking of how.
Do you want me to check it again? No, you got it. All right. Just get, okay, that's fine. But draw. Yep.
Oh, yeah, right. It's opposite.
It's off a little bit. Just a little bit. It's off a bit.
Yes. 2-4.
Not two. It's negative 2/4.
Wait, Mr. Ray, what is our homework? Or will we get it next time?
All right, guys. Yeah, we're going to finish this up. We got one little piece, and then you're going to get time to do some graphing. Very good. I'll give you more difficult ones, Caroline, since that's too easy. Trust me, it can get tougher. But you guys did very well. I'll see you this